Live. It says we're live.
We're live.
MI350X, 355X just launched. Hopefully you caught the live stream. I'm here with Crafty Jeff.
Hello. Hello. I'm here with Wendell. We're simulcasting, so if you want the multi-view a la ESPN, you can have us both up at the same time and get two different camera angles.
Yes. The audio is probably terrible, but that's fine.
I guaranteed. Yeah.
There's fun AMD stuff behind us.
Yes, there is.
There's some mechanical samples or dummies or something.
I don't know if they're dummies. They look like finished wafers to me. But,
they always do.
Yeah. Yeah, we'll see.
I lost my stand for my camera, so it's down very low. Enjoy your view of the ceiling.
Yes. Yeah, Wendell's view is going to go like right up our nose. I actually have a little stand for mine.
It is actually nice. Like, yeah. It looks all pro.
Right, yeah. I'm getting better at the live streaming from weird events setup. I literally brought my backpack and that's it.
Yeah.
For the whole show. That's my clothes. That's everything.
I packed some stuff in my luggage because I was like, I don't need this because I'm gonna get on my flight, and it's like, oh wait, yeah, because we don't have a hotel room. It's
yeah.
It's fine.
Yeah, we're both flying out today, so checkout was 11 o'clock, which was 30 minutes before the keynote ended.
Yeah.
And so we had to clear out and bring all of our stuff to the keynote.
But we're here to chat about anything. You can ask questions.
Yes.
And the studious among you, like if you watch the AMD live keynote and you have questions,
here we are.
Now's your time.
Yeah.
Chat. Ask questions. We already have like 2 people in the chat.
Yeah.
Which is great.
I've already got a super chat. Parker sends over $10 and says AMD. Woo! I kind of agree with that. Yeah.
There are a lot of. I noticed there were a lot of salty people when I was sort of tweeting and doing some stuff earlier. There's like a lot of needlessly salty people, and it's like, why? Why you gotta be like that?
Yeah.
Is the world so bad that you feel the need to just crap all over everything? Like maybe you should re-examine your life choices.
Yeah. So I guess let's just go like big impressions. Like what did we think?
I'm really surprised that they were able to pull Sam Altman on stage.
That was kind of a shock. I heard a rumbling about 5 minutes before it happened.
But also that tells you how many GPUs that OpenAI is buying.
Yes.
Like a lot.
Yeah, when Sam and Lisa hug on stage, there's a lot of zeros on that check.
Yeah, you go for the hug, it's the handshake, his shoulder pat, what's going on with that? So MI350 also, it's an interesting architectural departure from, because it's 3D packaging now instead of 2.5D packaging.
Yeah.
And so it's not really an incremental. I mean, 350 suggests like incremental upgrade because like 325 was like, oh, let's just turn up the TDP.
Yeah.
350 is, oh, this is different.
Yeah. Completely architectural difference. To most people, if you just read the spec sheet, it is going to seem like kind of an incremental bump. It feels like MI300, but just it's MI300 plus if you read the spec sheet. Yeah, they tied AMD from memory, or tied NVIDIA from memory, 288 gigs per GPU now. They've kind of tied them on memory bandwidth, both NVIDIA and AMD on B300 and MI350.
I think the total memory capacity from AMD is 1.5 times the max that you can get on NVIDIA.
Is it?
I think so.
No, it's 288 per GPU. I think in the single GPU domain, I think it's 1.5 times.
Okay.
I think is what that was. But yeah, it's 288 per GPU and it's the same bandwidth per GPU.
Yeah, because HBM.
Yeah. They're both HBM3E now. So a lot of parity going on. And I actually haven't dug that deeply into the claimed performance numbers. I don't know if you have.
FP6 is probably the most impressive.
Yeah.
And the secondary thing for FP6 is Ubergarm on our forum has been working on quantization. And I've actually got a video coming out where we did our own quants on DeepSeek. And we were able to produce a version of DeepSeek that's only about 300 gig big, which says a little less than half.
Yeah.
And that was a Q5 quant, and that has the same perplexity almost as the full fat 700 gig model. So it should perform identically.
Right.
And so I looked at that and I looked at the FP6 performance, and the FP6 and FP4 performance is identical because AMD spent extra transistor budget on FP6 to make it the same speed as FP4.
Yeah.
And so I'm thinking, our Q5 quant and FP6, that might have been a really, really good bet by AMD because FP6 is absurdly fast with MI350.
Yeah. I know Tobias from the Register posted an article right at the embargo, kind of going over some of the claimed numbers, and we saw NVIDIA launch B300 at GTC and that big announcement. AMD came in and seems like they're going to be going blow for blow depending on what your workload is.
Yeah.
With a lot of what NVIDIA announced.
Well, I think the other part of that is like, okay, that's on the GPU side.
Yeah.
NVIDIA is talking about things that aren't even rack scale. They're talking about things like, oh, this is the AI factory and the software enablement and blah, blah, blah.
Yeah.
And AMD is still sort of more focused on like, okay, let's bring it down out of the clouds back into the trees.
Yeah.
It's like, here is the forest. Here are the type of trees that you can buy. AMD is talking about rack scale and cooling rack scale, but they also were talking about networking and the fabric and other parts of that, because, it's like, how do you get around the networking connectivity? It's like Ultra Ethernet and the Open Compute standards. Like, all right, the Open Compute Consortium, whatever these enterprises decide they want, we will build for them. We will build to the standard. And they said at least 50 times the future is open, which is very encouraging.
Yeah, that was one of my big takeaways is looking at NVIDIA's presentation for B300, GB300 super chips, all that kind of stuff, is while NVIDIA does have the option for Ethernet as a backbone, basically every other component of their stack, of their rack scale stack, was proprietary. It was NVLink, it was InfiniBand, it was everything else that NVIDIA builds, which, yeah, that's how you get the tightest integration is by doing that. But AMD came out and said, no, we're supporting basically full open standards.
Now, somebody would probably point out that NVIDIA said that they were going to open the intellectual property for NVLink, and you could deploy NVLink on anything.
Yeah.
Unfortunately, that's still a black box.
Yeah.
If they really wanted to open it, they could have contributed to Open Compute, but they didn't want anybody else to adopt it immediately. So it's not an apples to apples. Like, yes, you could see NVLink in other products, but it's still a bit of an intellectual property black box until Open Compute, until they pledge open standards, until they pledge whatever else. Ahmed Ali asked if we've looked at the unsloughed quants. Not only have we looked at the unsloughed quants, I think our Q1 quant is better than theirs. Stay tuned for the video.
Yeah.
No beers? Yeah, we're doing this a little bit on the fly, sorry.
Yeah,
I got water.
I do have, hold on, I've got a bubbly. I grabbed a beverage just in case. I did think about sneaking in an IPA, but...
What is that?
Yeah, I've got a raspberry bubbly today, so, yeah.
Thank you for hanging out and chatting.
Yeah.
We've only got an hour to do this, so you gotta get your questions in.
Yeah.
So networking fabric, full rack scale. We got a preview of MI400 and what they have planned for Project Helios.
Yes.
The only thing I can think of two things as Project Helios. One, reference to Deus Ex. Two, the amount of power that's going to be required because we need nuclear fusion yesterday.
Yeah. And I don't know if we're going to get nuclear fusion by 2026. But
we might.
Yeah. I mean, 3 miles starting back up.
That's Microsoft, yeah.
Yeah.
We're going to do that. It's going to reboot we need all of the power. Mm-hmm. We need all of the power. A lot of people have also made the joke about the matrix pods is like your body heat needs to be captured to use for electrical generation because the AI must feed.
Yeah. Well, unfortunately, like, humans do generate heat. I think the spec, I actually read the spec yesterday that your brain does about 12 watts.
Yeah.
So you're outputting about 12 watts of heat when you're thinking.
So when does ROCm support come to Windows for 9000 series GPUs? If you go download the ROC right now,
today,
you can kind of do that with 9000 series RDNA. I mean, obviously, AMD's putting the most focus on CDNA, which is what we learned about today.
Yep.
But the ROC on GitHub and Windows native, like they have that planned. There's a lot of people that are looking for Windows native, even though NVIDIA is kind of moving away from Windows native. NVIDIA is kind of leaning on WSL at this point.
Yeah.
For a lot of I mean, obviously the Windows drivers, but like the higher level, the GUI plumbing, and it's like, oh, we're going to run Python for Windows, and it's no, WSL.
Yeah.
But there's a lot of people that are asking after full Windows support for ROCm, and that's there. Like the ROC, the direction that they're heading on GitHub with the ROC is incredible, and definitely worth a look.
People are asking, what is your laptop? That is the GPD WinMax 2, and Wendell and I were almost twinsies, so I upgraded my laptop just a couple weeks ago, right before Computex. I got a new M4 MacBook Air, and I love this thing, but for the last 2 years, I've also been rocking a WinMax 2. Like, yeah.
It's 8 cores and 64 gigs of memory. What's not to love?
It's so great. Yeah. One of my favorite laptops of all time is definitely that thing.
Potato says, if stress generated electricity, he'd be a power station. You and me both, buddy. You and me both.
Hey there, doctor. How's it going? Let's see. I would love to hear Wendell's thoughts on the poor uptake of 10 gigabit PHY found in AMD's EPYC SKUs.
I think that 10 gig is old news.
Yeah.
It's mostly 25 gig. So like if you want to go 10 gig, you got what? Quantia and Broadcom. And so like just go 25 gig. And 25 gig is going to make a lot more sense. It also chews up lanes. So you don't have any, you only have the 8 utility lanes and they're PCIe Gen 3, and they're generally used for other things. AMD, I think with Naples, tried to have an on-chip 10 gig solution, but that was not well received.
Yeah.
And so 10 gig is actually like long obsolete at this point.
Yeah.
And 25 gig is the way to go.
Yeah.
I've also been surprised in like Proxmox clusters. I've noticed that like CoroSync runs fine even over a single gigabit network. But we've gotten CPUs now that are so fast they can like legit saturate 10 and 25 gig interfaces, which can interfere with the CoroSync service on Proxmox. But all the problems are eliminated even if you just use a 1 gig network for the CoroSync network, assuming that the rest of your network is not absurdly fast. So it's 10 gig is like it doesn't make sense to have SFP plus. That's not worth the cost.
Right.
And copper 10 gig is just kind of like almost a utility connection at this point. So
yeah. Copper 10 gig, we're finally starting to see a consumer uptick in it. We're starting to see like Threadripper boards come with it finally on board instead of 2.5. But
I think the reason it's been left off consumer is just because it's a problem dealing with the heat it generates. If you look at like the Asus workstation boards, every single one of them has had problems with proper cooling of the 10 gig chipset for the people that actually try to use it.
Yeah.
It's like, I'm going to peg the network at 100% all the time. And it's like, that's a problem on those boards, keeping it cool. Our forum is littered with people having trouble.
Yeah. On top of MI350, which is MI350X and MI355X, I guess we could talk a little bit more about those.
355 is liquid cooled.
Yeah.
That's the difference. 1,400 watts versus 1,000.
Yes.
And that is a power savings in the data center.
No one's looking at the chip. I'm going to go snag a chip.
That's a power savings, kind of. I mean, it's 400 watts, and you look at it, it's like, oh, it's 10% faster. In reality, it's actually 20% faster because we're not talking about like peak floating point throughput. We're talking about sustained, and the liquid cooled solutions can sustain better. But also, because it's liquid cooled, less of your overall power budget for fans and everything else are going to things that are not in the GPU. So, yay.
Yeah, liquid cooling solutions, you can do a lot more dense packaging of the systems. You only need 2U solutions for the servers themselves instead of the 4 or 8U solutions for the air-cooled boxes. Also, 1,400 watts of power goes directly to the GPU rather than the 1,000 watts, which you have to split up with 10 or 15 or 20 fans inside of the chassis itself, times 40 sometimes watts per fan.
Yeah.
You're a lot more power required for doing air cooling.
That's a lot of HBM stacks.
It's a lot of HBM. Yeah.
There's only 2 I/O dies now that are back to back. So in PS2, in PS4 is not a thing anymore in PS2, but you can also do SR-IOV partitions.
Yes. Yeah. So
a double wide rack for Helios. Yes, that's true too.
I'm probably not supposed to have this on the table, but I'm taking it anyway.
Better to ask forgiveness than permission.
That's right. Yeah.
Look at all the chiplets. Oh my god. But it is insane that thing uses this thing dissipates 1,000 watts or 1,400 watts.
1,400 watts. Yeah.
Like it's got to glow. I mean, not really, but.
One thing that's amazing is look how incredibly thick.
That's a lot of layers.
Yeah.
We should have asked how many layers the PCB is.
I'm surprised no one did, and I'm actually mad at myself that I didn't ask. Because usually that question comes up, is how many layers is your PCB?
I think think the state-of-the-art number of layers is over 100.
Yeah.
I don't know if that one's over 100, but...
Yeah, I know NVIDIA, for a lot of their things, they're using 72 layers for like DGX station and things like that. But
Aiden Pride says, are you saying that 10 gig generates more heat than 25 gig? Not in aggregate, but if you take into account like the SFP modules and things, there are more energy efficient 25 gig modules than there are 10, especially older 10 gig.
Yeah. When AMD found out I was going to be doing the podcast again, last time we did the podcast, I did the podcast last year from their Advancing AI event. Jordan decided to snag every sample he possibly could and bring it over. And so the question I got is, are you going to be stealing all of our samples again? And I said, maybe.
That was technically Jordan's fault.
That was technically Jordan's. I had no part in that. None at all. Maybe some slight encouragement. But...
Yeah, this is an absurdly, this is like the state of the art. I don't know. It's like, do you think this will be the generation that we see general artificial intelligence?
No. No, I still think we are so far away from that. The story this week, the kind of meme story was ChatGPT lost at chess to a 1 megahertz Atari chess simulator running on an Atari 2600. And the reason for that is because while generative AI is getting very, very good at generating what we think should be the output, there's still no logic behind it.
Dr. Cuttress says this is a 24-layer PCB.
Okay,
everybody
24.
should go subscribe to his channel. It's very good.
Yes, Tech Potato. Friend of both shows.
This seems absurd that this is only 24 layers. Like, I wouldn't think that you could get it done in 24 layers.
I would have said 36 at minimum.
Yeah, that's sort of nuts.
Yeah. Green Protagonist sends over $5. Thank you so much. Thoughts about the over-specialization / build into throwaway tech? I think ASIC after mining is dead. I think of enterprise now, eBay later. We are starting to see more and more specialized single-purpose hardware versus general compute. Because if you think of a graphics card is general compute. You can throw whatever API onto it. You can run whatever load you want on it. Same thing with x86 CPU. We're starting to see devices like MI300, devices like B300 that are much more specialized. They do certain calculations, and that's what they're designed to do.
I've been kind of surprised that there hasn't been, so like the specialization that we really see in something like this is like the FP4, FP6 specialization. It's less ASIC specialization. Mm-hmm. You have other companies that are
ASIC's
doing,
kind of the next layer.
Yeah. You have other companies that are doing interesting things like the Cerberus wafer scale thing and all that sort of stuff. And you could argue that is a kind of specialization, but really this is still just things for doing floating point math. If you look at FP64, like how much does FP64 improve generation with these? Not a lot.
Yeah.
And in fact, FP64 matrix is a bit of a regression.
I would say it's a bit slower on these.
Yeah. But no one is using it in that way for these kinds of applications. Yeah. So if you need that and you're like in a research type scenario, you know to buy another product. And that's true of everything in the market, I think.
Yeah.
So how you run an 8-way UBB in your home lab? There's PCIe. Don't need to run. UBB's fine. It's just power. I mean, you could run one. It would be hard to run 1,000 in the home lab, but you could run one.
Yeah. You can't really run it on watts. You can't really run it on 110.
That's only like 5 dryers worth of energy. You can do that on a North American power plant. Not a lot of room for air conditioning.
Yeah, you get 160 or 200 amp. My thought was literally just unplug my furnace in the winter and plug in this instead.
I get heat and useful compute as opposed to just heat.
Yeah, I've got 240 60 amp times 2 for my furnace and heat pump. Like, why not? Zach wants to know how long before one of these ends up in his garage. That is Yakto. He is very famous on my server and Techno Tim's Discord server. I think you know of him as well. He's one of these small, humble home lab folks. His home lab looks a lot like your home lab.
I need all the electricity.
Yeah. He has 400 amp service to his garage.
Nice. My garage service is only $220, but hey, I'll take it.
Yeah. Let's see. Asking the real question, does Doom run on one of these chips yet? I don't think anyone's ported Doom to that, but I don't think there's any reason you couldn't port Doom over to ROCm and have it run.
Yeah, no, it should run fine. I mean, the kernel, there's enough machinery on the GPU to be able to do that.
Right.
In fact, you could probably run thousands of instances.
Yeah, that was kind of my thought. So, Vince, if you want to port Doom over to ROCm, that might be a fun test we could do. How many instances of Doom can we run?
Getting the output would be a little bit of a challenge. Maybe we could train a model. I don't know.
Ooh, yeah, there you go. There was the model that recreated Doom visuals, no input, but it would recreate like a level and have it play.
That was a little unhinged.
Yeah.
But it was a surprisingly useful research demo. I thought it was funny that the Microsoft researchers had to clarify, like, this is not going to put game developers out of a job.
Right. Yeah, this is recreating the visuals based on input of using Doom as the training. Just a humble 80,000 watt home lab.
8,000, not 80. Or like maybe 8,500, give or take.
Yeah.
So, but hey, I mean, there's other stuff in the home lab. It's probably over 10K.
Yeah. My home lab's about 1,200 watts at this point. So.
Or 12,000 probably. 12,000 or 1,200?
1,200.
Oh.
1,200 watt.
That is surprisingly good.
Yeah.
Mine is not.
I got mine down to sub 7 at one point.
Wow.
Yeah.
Yeah, you're fine then.
Yeah.
I have lots of things that I don't want to turn off because I'm lazy, and it's like, this is costing a non-trivial amount of money in electricity, and it's like, I'm kind of lazy. I don't want to turn that off. It's like I wake up in the middle of the night. It's like, I have an idea. Let me remote into that system. Yeah. Oh, wait, I turned it off because I wanted to save power.
Right. Or I wanted to sleep and the fans make too much noise. My bedroom shares a wall with my home lab, so. Yes.
There's the answer.
Yeah. You can't hear it all the time. Like, if our HVAC the fan isn't running and whatnot, you can sometimes just imagine the sound of the fans. Like, they're present, but they're not that bad.
Even Steven's like, I'm interested in the price, and it's like, if you have to ask about the price, you can't afford it.
Yeah, that's exactly right. Yeah.
See, the customers that are buying these are buying them in such a volume that they're negotiating.
Yeah.
We could give you the price per hour if you want it in like Vultr or Azure Cloud or something like that. You know, it's going to be on the order of a few bucks an hour. Mm-hmm. If you're a developer, you have a .edu address, you can get a ROCm developer account right now or an AMD Dev Cloud and get access to CDNA GPUs right now, like in the next 10 minutes. You got a GitHub account with some history or a .edu, you can get, a day of access to these GPUs. Like, that's a thing.
Yep. Yeah, during the announcement today, if you guys watched the keynote, they also said everyone in that room got a 25-hour account right off the bat. So yeah, we can go play with them literally right now. So.
I kind of like that.
Yeah.
That's a lot of fun. And also you can play with the new ROCm.
Yeah.
Which I was surprised as heck I was able to pull in ROCm 7 preview edition. Or preview version.
I was actually just going to transition over to ROCm talk a little bit. So ROCm 7 preview announced today and full release as soon as it's ready, kind of thing. But one thing that they're trying with ROCm is they're really trying to unify it across their entire product stack. So that's Strix Halo, that's Instinct Pro, and then their data center products. As the funniest interaction I've ever had with Wendell was as soon as he heard that, he goes, ROCm works on Strix Halo. He goes, shit, it doesn't. He pulled out his laptop and he goes, I'll be damned, it does. So during the demo, during the thing, they said, yeah, it's up for download right now. He was compiling it during the demo.
On Strix Halo.
Yeah, because of course he was.
So I did have to do a fresh git pull. There's actually a thread for that on the forum. It's not going to work with CMake 4. You're going to need CMake 3.5. But it's interesting too because graphics 1151, what's in this, the Vulkan backend is faster than the HIP backend, and so you really have three classes of GPU that you have to deal with: the APUs and RDNA. I mean, APUs have RDNA. This is RDNA 3 or 3.5 or whatever.
3.5, I think, yeah.
And then you have, RDNA 3 and 4 into the discrete GPUs, and then you have CDNA. And so these three things are three different levels of support from ROCm. And that, up till now, even continuing from now, has been exactly the mess that it sounds like, and not great for developers.
Yeah.
But that is getting fixed.
Yeah.
And eventually one contemplates that there's a road where CDNA and RDNA merge. That has not been formally discussed. There's only hints about that in the code base.
Yeah. They are kind of built on the same building blocks. It's just, again, graphics is more of a general compute. CDNA is more of a compute-specific architecture, but the building blocks of them are the same. The compute units have the same base architectural design.
Yeah, and I don't understand, at a low level, I kind of get it, but at one point, so in the kernel, it's like if you're doing like a wave operation or like a matrix operation, it's like you could do that, and then you've got like 2 clock ticks worth of stuff you can do other things for, and then you can do your next wave operation or something like that. Yeah. And I'm sure that somebody that actually knows what they're talking about is like cringing hard. But if you do a really amazing level of optimization, you can keep the GPUs fed at every step there, and that's a little different on CDNA versus RDNA versus whatever. And that's some of the optimizations that they're pulling into ROCm 7. That's why they can say, oh, we have a 7x speed up. But also those numbers are kind of cherry picked because it depends on which version of ROCm, and it depends on which level of hardware support, and it depends on which actual thing. So I have seen speed ups like that on, I've got some MI210s, I don't know, like 1 or 2. And
I have 2.
And the MI210 speed ups on ROCm like the last year is like, wow, this hardware is still really, really viable even though it's MI210. Like if they had this level of performance when they launched, it would be insane.
Yeah.
But the open ecosystem is also accelerating because I think like most of the graphics 1151 for this is from the community. And I can't remember your name right now, but some unsung random hero for graphics 1151 bringing up Strix Halo is like done some amazing work, and I can actually kind of use it because of a couple of internet randos. And AMD's been busy, I guess, with CDNA and MI355, and there's more hardware changes under the hood for MI350 and 355 that translate into like the whole FP6 thing and the performance there. So yeah, it's really interesting seeing it all come together.
Yeah. Let's see. What other questions do we have here? People are starting to take guesses on how many copies of Doom we can run. I think that needs to happen now. I think we need to port Doom to ROCm and use our 25 hours for the betterment of the community to answer that question.
See what you think.
Yeah.
It's like, do you think you guys can mod an MSA2 to run in a dual node rack setup, maybe 3D printed with the unmodded 4000 SFF to improve airflow of the Noxio A9. Yeah, you can do that. I usually do a three-way cluster. If you use your PCIe slot, you can definitely do a 3-way. You can kind of do a 3-way cluster over Thunderbolt. Yeah. But it's only a 20 gigabit interface.
Yeah. But with an unmodded RTX 4000 SFF, no. I mean, you would have to 3D print a taller shell to be able to use a dual slot card in there. Yeah. I mean, it's kind of possible, but I think you'd also be pushing up against 1U of rack space.
The Ada SFF 4000, there's a third party that makes a 1U copper heatsink.
Yeah, I have it.
It works.
It does. It still only works to about 60 watts. Like, you can't get the full 70 out of it. Inside the MSA2 specifically. Open air, it works just fine. But actually, and that's Nerdware is the guy that makes that. He sent me a new fan module for it that's supposed to be able to do the full 70 watts inside the MSA2.
Oh, nice.
I literally have the fan in my truck. I picked it up from my mailbox just a couple days before I left for here. So
nice.
Yeah, so stay tuned.
I have a 70 watt RAID card that I modded to put in the A2, and I ended up putting a very loud mini blower on it in order to deal with it. Yeah. And it's like, okay, sounds good.
Let's see.
Did you see Jensen in disguise? No, he was at GTC in Paris. AMD trolled NVIDIA in Paris. They hired a bunch of folks to stand around and dance outside of GTC Paris with signs saying, "Oh, we're launching the MI350," which I thought was funny.
AMD realized that I have the 350 on the desk here in front of me now.
They're lurking.
He looks over and he goes, "Hi, buddy."
It's fine. It's all good.
All right. I run Olama embedding models on my work machine with a W6600 using a custom compiled version of Llama CCP or CPP with support for it tuned manually. Works great.
There's so you should check out the forum thread, the DeepSeek at Home forum thread. IK just merged support, I think, in for the type of quantization that we're doing on DeepSeek, but I'm sure it would work on other models. And that patch speeds things up pretty significantly. So I think that thread is kind of interesting. You might want to check it out.
Can we run Vulkan backend for Llama CPP on MI210? Yes, because MI210 does support Vulkan API.
I don't know how fast it is though.
Yeah,
I was surprised. Like Vulkan should be an RDNA thing, but it's actually better than the HIP backend in an RDNA context. I don't know about Vulkan in a CDNA context, maybe.
Right.
I didn't think to try that.
Yeah. But yeah, no, unlike a lot of the Instinct Pro cards, the MI210 does still support traditional graphics APIs.
Yeah.
So your Vulkan, your DX12, your et cetera, et cetera.
Tech Potato points out, remember Sam Altman was at Intel last year and is now AMD this year. Why is he not at NVIDIA? He was at Intel for Gaudi 3.
Yeah.
And I've been tracking the Gaudi 3 GitHubs, and there's not been a lot of software movement on the open stuff that was promised for Gaudi 3, which is of concern.
Because there was supposed to be the whole one API tie-in and whatnot, and that never really came. I'm sort of worried about that. And when I asked, Intel's launching Battle Matrix on the Arc side, and I was like, how does this tie in with Gaudi? Is this going to be like a one API thing? And they were like, yeah.
So it's like, no. It's like, okay, nothing, okay, all right.
Gearling says hi.
How was the Micro Center thing?
Yeah, he's at Micro Center right now. He literally said, so Gearling didn't realize we were going to be here, and we didn't realize Gearling was going to be here. He's shooting something for the brand new Micro Center here in Sunnyvale, Santa Monica.
Oh, okay.
Something like that. And he goes, hey, I didn't realize you guys were in town. Can we meet up? And it's like, no, actually, my flight leaves at 9 o'clock tonight.
Yeah, mine leaves. Dr. Cuttress has the most amazing joke. It's like, there's been no update for Gaudi 3. Are you sure? As in Falcon Shore.
I get you.
Are you available for writing gigs? Can you write my jokes for me? That'd be great. Patrick's here too. Yes, he's lurking about. Actually, if you pay attention to the background, you will have seen Charlie Demergian and Patrick Kennedy and probably about a dozen other people. Vic from Supermicro was here. A lot of the AMD insiders, like the people that are like the Silicon Whisperers, if you will, bringing all this up. They had the ROCm team here too. They really did a nice job letting the people that are working on the programming on the ROCm side, out to talk. And it was like, hey, as an internet rando that doesn't know what they're doing, that's just banging on the keyboard with my forehead, that's me. Here's what my experiences have been. And they're like, oh, you poor thing. And also, we need to work on that. And also, oh, you're doing it wrong. Here's how you should do it. And I was like, oh, great. I should do a video on how to actually do it correctly. So, fun times.
That's one of the more frustrating things that I experience. You and I both trying to do really weird things with hardware sometimes is, sometimes there is a right way to do things or a best practices way. Maybe the documentation isn't clear, but you and I spend 6 weeks banging our head on a keyboard.
It's the thing is that this is such a frontier, and there are so many companies that are at the forefront. If you haven't been there from day zero, you don't necessarily have the context to get up to speed really quickly. And it's like, I just want to hop in and learn what I need to know, and then hop out and go do another thing, and then hop in and like learn and catch up. And sometimes it's a little bit of a blind alley trying to catch up, because you catch up and you read what everybody's worked on, but then you get to the end of it and it's like, oh, it's decided this is a blind alley. Now we're going in a different direction. And it's like, okay, well, let me just uninstall all this horrible software stuff that I did to try to make it work.
Gearling says, sounds like a fun event. Hopefully we get Rock'em on ARM someday, too. Vulkan is great, but Rock'em would be fun on the Pi. That would be a lot of fun.
Yeah.
To toy around with.
I've run into I was trying to get the Rock working on, and there are like compiler macros and things like that, but at a PCIe level, there's probably not a huge impediment in getting it to work on ARM, because it's just going to feed the GPU. Yeah. But it's all, I think that most of the landmines are going to be like all of macros and like just crazy stuff in the build system. Rock'em also depends on a lot of third-party libraries that are bundled, and so when you install it, it's like, oh, let me go get all the dependencies, and that's where I ran into problems trying to bring up Rock'em on the 1151.
Yep.
Jason, Rock'em on ARM is coming. It's called Fujitsu Monica. It's coming 2027. Oh, thanks, Technical.
Nice.
That's interesting.
Jason says the Pacific Northwest needs a Micro Center. I've been yelling at Micro Center forever. So we used to have a Fry's in Wilsonville, Oregon, and that closed when Fry's went out of business. The Fry's building is still open. It's still vacant. So I'm like, Micro Center, just literally move in. Like, just start shipping product. You can change the signs later. It's fine.
I'm an hour and a half from a Micro Center, and I abuse the crap out of it.
I am much further. The new one here in the Bay Area is now the closest Micro Center to me. The old one used to be Denver, which was 900 and something miles from me. This one's only 600.
That's still pretty rough.
Yeah.
It's not worth a 10-hour trek.
Yeah, exactly. Yeah. So they're getting closer.
What are the chances we can get an AI Sean Connery saying, "Welcome to the Rock'em" when you boot it up? I'm literally going to cue that right now at my home cluster. It'll be done by the time I get home.
Excellent. Welcome to the Rock. Fricro Center. Wendell and Jeff, did you hear anything concrete from AMD that they will improve Rock'em for Olama and such now that 395 Plus Max 128 pops up on YouTube a lot? Actually, yes.
So there's a bug that I found I was like, hey, what's going on? And AMD put an engineer on it, and there is like a 4-month history on GitHub. So not only have they been working on it, it is dramatically way better than it was.
Yeah.
Llama.cpp is at the forefront, and Olama like inside the Olama container is llama.cpp.
Yeah.
And they lag behind a little bit sometimes. There's some out-of-tree patches for llama.cpp that you can go to like the pull requests, and there's the ones that have like a lot of comments and stuff make sense. You can go inside the Olama like Docker container and manipulate llama.cpp directly, like that's fine. And so it's better than it's ever been, and I've been surprised how good it is, because like a year ago I was really like struggling and pulling my hair out, and the last 6 months especially it has gotten dramatically way better. Yeah. But also on our forum in the thread, patches for llama.cpp in and out of tree, and you can use that with the Olama front end. Cool. So it's fun and exciting. You guys have any other questions about anything else that launched today? We've got 20 minutes.
Yeah. Let's see.
It's a relatively standard interface too.
It is, yeah.
It's the open compute thing.
Yeah. It's a very pretty card.
You know, Open Compute has their own rack standards as well. It's not the 19-inch rack.
Right. Yeah. 21?
21.
Yeah.
And so it's just like, do we know if it's, do we know, Dr. Cuttress, do you know if the rack was the Helios rack is the Open Compute rack, or it's just a double wide?
I believe it was the 21. I believe it was the Open Compute rack.
It looks pretty chunky.
I mean, I didn't take measurements. They obviously don't have anything here, but it looked a little squatter, a little wider than a 19 would on the renderings that they showed. So I would bet it's based on Open Compute standards, because that was actually a big part of the presentation was
that an open version of the SXM2 type slots? Yeah, basically SXM2 with more power delivery capabilities.
Exactly.
And some other, but open. It's an Open Compute standard.
Yeah. So.
UBB.
Yep. Let's see.
I'm sure it's 38 inches wide. Siemens has their emulation silicon in double wide. Ah, okay. Interesting.
Merle Squirrel and Friends wants to know, will there be a 9070 XTX / Halo card? I don't know, will there?
They're not talking about that here.
Will there be a 9070 XTX Halo edition card? Like, I'm getting that. Okay.
AMD Ryzen AI Max 395 Plus still not supported by ROCm on Linux. That is not technically true, Mino. If you want to download Ubuntu 24.04 LTS and hit up the forum and make some minor changes and make sure that you don't have CMake 4 installed, the graphics 1151 target will build. If not, hit me up in the forum. I guess officially supported is accurate. Community supported, there are patches.
Let's see. What else do we got?
Like, that's what I was working on while I was here. Like, in between the sessions and things, it was just like, I was trying to get the ROCm to where it would build on Arch. I'm not quite there yet. ROCm will build, but not for the 1151. But the 1151 support will work with an older Clang compiler and CMake 3.5 dot something, not CMake 4.
Yeah. How many BSDs can that chip run?
I mean, if it's like micro BSD, you could probably run like, it would be a lot.
Yeah.
Because you got, 288 gigs of HBM3.
Yeah.
I mean, it'd be a lot.
And you can SRIOV it, so you can containerize them and have a lot of fun with that.
Don't forget, if you don't want to deal with, like quote-unquote ROCm support issues, deploy in DevCloud and like go play with it in DevCloud. Because if you have issues in DevCloud, then that's good because feedback. But if you don't have issues in DevCloud and then you have issues locally, then there's a path to getting it fixed. But if it doesn't have issues in DevCloud, then you can have the confidence to deploy the hardware solution that you need for whatever.
Green wants to know, is anything pointing to tech that will trickle down to the consumer space?
No.
No. Not this. Like I said, MI300 or MI350, the enterprise products that we're seeing from NVIDIA, AMD, Intel right now, they're kind of similar building blocks, but they are their own hardware. Areas like graphics are going to still benefit from the developments that happen here, but it's not like a direct trickle-down thing. I think it's the best way to put it.
Has there been any more detail beyond 180 kilowatts per rack and what the future might be? Not really.
Yeah.
They didn't really even specify 180 kilowatts per rack. If you do the math, it's like 160.
Yeah, but, 160 is what I was coming up with.
20 kilowatts of overhead? Okay, yeah, sure, maybe.
Let's see.
Just to be clear, the notebook that I have is the 395 plus max with 120 gigs of RAM. Yes, G1A. Done several videos on it. Check it out.
Yep. Praetorian says, finally got SRIOV pass-through working on the MSO1 a few weeks ago, so ask Wendell if he's proud of me.
Yay, yes. Good job. That is amazing. Now, did you use the Intel GitHub repository for that with the walkthrough, or did you use the Strong SV helper repository, or both?
I have tried to use the Intel repository for that before, and I have not had much success.
You have to you have to find the branch, or you have to cherry pick the commit.
Yeah.
Because it's just like, I'll use head. They don't test.
Yeah. But can it run Crysis? No, actually. These don't support standard graphics APIs. They are compute only. No Vulkan, no DirectX. I don't even think they do OpenGL. It's OpenCL.
I heard something about 2.5 versus 3D packaging on the MI350. What does that mean exactly? So 3D packaging is true 3D packaging. We're silicon on silicon. Like, it's easy to manufacture. It's hard to assemble. They've cracked the nut on assembling. The I/O die is only 2 I/O dies now, so they're able to. I mean, they can pack this in a relatively small footprint with an ungodly number of HBM3E stacks.
Yeah.
And so this is a totally different situation in terms of like mechanical assembly. That actually frees up a fair bit of power budget versus the 2.5D assembly process, I guess, which can then be dumped into more for the GPU. Although interestingly, I think there are fewer compute units at a higher clock or something like that versus MI300. One interesting thing about the choices they made with the XCD chiplets that they call this for graphics is the direction that they've gone. With MI300A, you could replace some of the compute with CPU compute.
Yes.
So you could have 24 Zen cores plus, and that's how you got the MI300A.
Yeah.
There is no path for an MI355A or 350A,
right,
with the way that they've redone the compute chiplets.
Yeah, they're kind of banking on running Turin in the rack as kind of your control head now, rather than making devoted like APUs out of these packages anymore.
Now we might see an APU in MI400.
Yeah,
maybe, but probably not.
Yeah,
I mean, I don't know. We'll see. Did anybody get a GMY Tech 395 Plus? No.
Nope.
It would be nice though. I would try to get Rockham working on it and then post the guide on the forum.
Hint, hint.
Are you able to offload more than 16 gigs of layers to the graphics 1151? Because that's where I'm stuck. Yes. Do you have, like Doc Brody, are you using Windows or Linux, and are you using the G1A?
Better 3D assembly sounds like something that would trickle down. Yeah, as far as packaging goes, that is something that is a development, but they were working on that anyway. I mean, that's what Intel is using for Arrow Lake.
I think several of these technologies are basically pipe cleaners for what they have planned for MI400.
Exactly, yeah. Not sure how I feel about these getting further and further away from desktop. I've talked about this a little bit on my channel, that as enthusiasts,
a wild Patrick appears.
Come on, you're fine.
Say hello. They were asking about you earlier. They literally, the chat was like,
"Hey guys,
you gotta
Oh, sorry.
Yeah.
There you go. Say hello.
Hi, buddy.
Hey guys."
Look at that. Dr. Potato asks, when's the next event? I don't know.
Yeah. Supercompute?
Maybe.
I think it's the next thing we'll all be at.
I think September's going to be a busy month.
Yeah.
And then I think that supercomputing will be big, and then 2026 is going to be fun. So.
Yeah. Yeah. A lot of things point to 2026 being some very, very
PCIe
large flagship style
PCIe
events.
Gen 6 is already here in Blackwell.
And ConnectX 8.
And ConnectX 8.
Yeah.
Yeah. But
Yeah.
No CPUs.
But yeah. Cool. Hi guys. Well, I hope you guys have an amazing stream. It was great seeing everybody. All right. Take care.
Bye.
Yeah, I've talked about this, like specifically for like the home lab crowd, because we love taking used enterprise crap, using it for ways it was never intended, or using it for ways that it was intended, learning on it, plugging away at it, that kind of thing. The latest developments for data center, for big data, because NVIDIA's no longer building like a full suite of SKUs across like an entire product range. NVIDIA only builds B300 now for data center. AMD is only building MI350, MI355 now.
Which is the same, it's just physical configuration.
Exactly. Yeah, these aren't ever really going to land in home labs. I mean, outside of us.
Now here's an opportunity for you to plug Unix surplus.
Yes. I would I did say on the stream last week that Unix Surplus is sending me a DGX V100.
Yes. Those are the kinds of things exiting the data center. Now, when did those first show up in the data center? 2019?
2019, 2020.
Okay.
Yeah, that was right between Pascal and Turing was when Volta hit the scene, and Volta was supposed to be the upgrade to Pascal, and in fact, on like the gamer side of things, raw rasterization is even faster than Turing was, but they went with Turing with ray tracing, and kind of the rest is history there. So yeah, I've got some big plans for the V100 system, both running some smaller AI compute kind of things. I've also got full permission to do full virtual gaming rig with it, so 16 players with some V100 32 gigs.
Yeah, you can split those up. vGPU works natively on that silicon, which is great.
Yeah.
And 32 gigs of VRAM is like legit.
Yeah.
I mean, that's the same amount of VRAM as a 5090.
That's right. Yeah. So
and those are just now hitting surplus. So we're just starting to see MI50 and MI100 as surplus. Not a lot of those were created, but V100 as surplus is happening right now, and so you can buy those. And if you're a researcher that needs like FP64, V100 is great.
Yeah,
FP64 hasn't improved dramatically since
I would say FP64 performance on that is basically the same as what we're getting with these newer chips. So if that's your workload, you'd be stupid to buy anything newer.
I'm looking at getting a quad NVLink V100 board. How's this any different as far as getting old weird stuff? It is all packaged and ready to go. Like you could buy the complete system and just it's turnkey.
Yeah.
And that's SXM or PCIe. I think they have both configurations.
Yes.
But there's listings on eBay for Unix Surplus. You can check that out.
Yeah, the chassis that I'm getting is an Inspur 2U box, and it's the SXM chassis with 8 V100s in it. They did have some PCIe, loads and loads of PCIe chassis if you're looking for like a bare chassis, build your own kind of thing, as well as some V100 PCIe cards. So. But yeah, no, I had a great conversation with the guys over at Unix Surplus Tuesday evening and Wednesday morning both, and there's going to be some fun stuff coming up on the channel, so stay tuned.
The fun thing with V100s is you can use them for fine-tuning, but if you use formats that are smaller than like FP32, you don't get the speed-up benefit.
Right.
And like Frontier models, when they say that, the Frontier right now is like FP8, maybe FP6. Like I was blown away that some randos on the Level 1 forum were able to do effectively an FP6 version of DeepSeek that has absurdly low perplexity, but at FP6. And so like if you have hardware acceleration for FP6, then boom, free performance. But if you don't have hardware acceleration for FP6, it'll run at FP8 speeds, or if you don't have FP8 support, it'll run at FP16 speeds. So it just depends.
Mike says, how has AMD addressed cross-die latency challenges introduced by chiplet-based Infinity Fabric scaling, particularly under high-throughput PCIe Gen 5 conditions in multi-module deployments?
So
Number one, great question.
That is a loaded question, but also the 3D stacking does away with a lot of the concerns that go with that. They were telling us that the interface in 3D is basically just like having a native wire. So this 3D interfacing, like you still, like, okay, it's still an 8-way Infinity Fabric connection to the other GPUs, but for the resources that are on this chip, the penalties are much lower in the 3D configuration than previously. Than with the 2.5D.
Each of the 8 chiplets has, 4 megs of L2, and then it's got a shared 256 meg Infinity Fabric cache.
I don't know, I couldn't tell you the numbers off the top of my head.
I believe.
But they're very effectively leveraging Infinity Fabric. The other thing is Meta shared that 10% of their problems bringing up a new model are related to networking or network faults, and that's one of the things that Polara and the new Open Compute standard aims to address is a little bit more resiliency on that fabric without introducing more latency or overhead. And so we don't really have a lot of details on that, but it'll be interesting to see how that shakes out. But Meta was excited about that functionality, so it's going to help them. Will it translate into something larger for the market? We'll see.
Let's see.
Any other questions? It's your last call for questions.
We got 5 minutes left, and then we're gonna close up shop because Wendell and I both need to catch planes.
So many planes.
Yeah, we're gonna go have like a quick bite to eat, and then yeah, that's about it. Let's see. And I realized, I think this is the first time we're like officially on camera speaking words to each other, because we've like waved at each other in videos before.
No, we did the one podcast.
Did we do the podcast?
At I don't know where it was. It was somewhere. I wandered on and it was like, oh, stay a while. And
oh, that's right. Okay. Okay, yeah.
That's fine. What sessions are you guys going to later today? I'm going to try to catch one of the ones by the Unsloth guys are here, so I was going to try to catch one of those. There's actually a lot of developer sessions going on now, so this is like a dual press developer event, which is great. AMD should do more of that. I always thought that Intel's combination like press developer events were fantastic for the stuff that they were doing, and this has echoes of that, which is great.
No, it's been a really good vibe here too. Like,
a lot of the press don't care about like, oh, I don't care about how to like bring up Docker and do things, but we do.
Yeah.
Computech, Segfault, and friends. Jeff. Oh yeah. There. I forgot about that. Wait, is that live?
It's not live yet. Ian did share a very brief preview on his last Tech Poutine. I asked Wendell to be on my show, and then I had to preface with, "Don't worry, no one's going to sit on your lap this time unless you ask."
That was for this show, not the previous one, implying that happened.
Yeah. Maybe.
So that's coming at some point. I don't know. Still being edited. Fair enough.
Yep.
Would love to see Unsloth coverage. We have done a couple of videos on Unsloth. It's nice. I like it. So like the whole Llama Quinn, it's like, oh, it's DeepSeek Quinn. It's not. Quantization is the way to go. Quantization is not. We retrained Llama to talk like DeepSeek.
Yeah. Is the live stream on the guest Wi-Fi? I am on not the guest Wi-Fi. I am on the AMD event Wi-Fi.
I'm on my cell phone.
Okay, yeah. I think we resorted to that last year when I streamed from here at the Advancing AI event. The Wi-Fi there was not good.
Yeah. Sounds about right.
Yep. But no, I am on the Wi-Fi here. So.
And so am I.
According to OBS, 0 dropped packets the entire time.
Oh,
zero frames. Yeah.
I haven't even checked. I've been running off battery. You're running off battery.
I'm running off
right?
battery. Yeah.
I also have 0 drop frames at 5 megabit.
Nice. Yeah, I think I'm at 4.5. So yeah.
Nice.
Pretty similar. Yeah.
That's pretty amazing.
Woo.
Well, thank you all for hanging out. This has been a quick look at AMD's crazy AI event with crazy hardware and everything else. And it was interesting to see the announcements, and best of luck for the future.
Yeah. This was fun. Thank you, sir.
Thank you.
And hello, Level 1 Techs.
Oh yeah, you should go subscribe to Craft Computing.
Yeah.
Like there's a link. I think the editors added a link to this. I didn't set this up. I'm sorry.
Yeah. I've got a link to Level 1 Techs down in my video description because I'm good. I do the YouTube thing professionally.
Hello, is anybody listening? Can somebody do that for me? Thank you.
But anyway, thank you all so much as always for watching. This has been a really fun cast.
Yes, this is fun. It was a lot of fun.
Yeah.
And also, if you have crazy home labs you want to show off, definitely let us know.
Absolutely. One of the things I'm actually thinking about doing in the near future is home lab tours.
Oh yeah, that'd be fun.
Yeah, finding people with like really interesting things that they do and going and showing it off. So
I'm willing to show off all the megawatts. Do you still use the Ultra G1A? This one right here? Yes, I absolutely do. The GPD is running the stream, but this, I was getting Rock'em working on this. We talked about that earlier in the stream, so it's pretty crazy. All right.
Thanks everyone.
Thanks.
We'll see you later.